Good day everyone, I'm Darren Beltran again of PSEE3A. I create this short video presentation that will summarize and discuss the important topics in the two tutorial videos included in our module number 8. First topic we will discuss is about CPU. CPU stands for Central Processing Unit, often called the computer brain. CPU sits at the center of everything in the computer and handles all of the computation needed. CPUs are a general purpose, flexible architecture that take in a stream of instructions from all types of workloads and compute or process information based on those instructions. Simply put, CPUs do what we tell them or program them to do. CPUs are what run your operating system. Yesterday's supercomputer that once filled a large room now easily fits on a chip inside our laptop. Error-prone programming. The term bug has been used as a part for engineering jargon long before the ENIAC. ENIAC stands for Electronic Numerical Integrator and Computer. Fun fact: the silicon die of a modern microprocessor is smaller than the bug. In the late 1940s, prominent mathematician John von Neumann popularized a new kind of computer architecture that simplified computer design and programming. His idea for a stored program computer reimagined the general-purpose computer as these three separate systems: a bank of memory, main memory, for storing data and instructions; a central processing unit, for decoding and executing instructions; and a set of input and output interfaces. In 1959, Robert Noyce patented the first monolithic integrated circuit, which combined multiple transistors on a single silicon chip. These early chips didn't have many transistors, but they enable much smaller and more complex circuit designs. There are a couple of concepts that are key to understand with regards to computer architecture. First is the notion and use of the binary system. Second one is the computing abstraction layers. Digital computers use a number system based on zeros and ones rather than the decimal system. Building from one layer to the next allows us to build complex computing structures from the bottom up that would be almost impossible to visualize from the top down. Instruction set architecture. The instruction set architecture, or ISA, is a set of instructions that defines what kinds of operation can be performed in hardware. An ISA is an abstract model of the computer, sometimes also referred to as architecture or computer architecture. It describes the memory model, supported data types, registers, and machine code. Key building blocks in a CPU. What makes up the basic building blocks of every modern CPU? First step is to fetch or retrieve the instruction from memory. Next step is to decode the fetch instructions into notative operations. Once the instructions have been decoded, the CPU needs to execute them. Finally, the CPU will store those results. This is called the write back stage. Now that's what makes up the basic building blocks of every modern CPU. When put together, they are referred to as the CPU's pipeline. A pipeline is very similar to an assembly line. The more stages are added, the less is done in each individual stage. Speculations now is used to increase CPU's performance, trying to always guess where code is going in order to avoid wait times. Thank you for watching!